This is the first part of the solutions for exercise 8.7. So we're going to split this into two videos. So exercise 8.7, here they've given us a proof for how this formula can be proven in n. And now in lines 4 and 5, they use a rule called PL, so for propositional logic applied to first line 3. And then in line 5 they apply propositional logic to line 2 and 4. So what does it mean when they use PL as a justification in a proof? Well, it just means that something is provable using only axiom 0 to axiom 3 and modus ponens in propositional logic. So then we just write PL next to it. So for example, if you were using corollary 418 in a proof, here you would just on the side write PL col 418 and then whatever line you're applying it to, meaning that this is provable in propositional logic and I'm using corollary 418. But here they haven't really listed what rules they've used, and we don't really know why this is admissible in propositional logic. So we have to verify that lines 4 and 5 are in fact valid transitions according to propositional logic. So first, what does line 4 actually do? Well, line 4 uses a type of rule where we have A implies B implies existence of X in A implies B, and then we get negation of A implies existence of X, A implies B. So this is a rule of the type of the form A implies B implies Z, where Z is existence X, A implies B. So if we have that, then we have the negation of A implies Z. So here we have the negation of A implies our Z here. So we want to show that this rule is in fact admissible in propositional logic. So first we can check if the rule is sound. So to check if the rule is sound, we can use a truth table to see if for all values that the assumption is true, the conclusion is also true. So for all values that this is true, this here is also true. Now I'm not going to waste your time on setting up a truth table. I have one here. So if we just move this up here, oops, there we go. There. So we have the four propositions A, B, and C, which means that we've got 8 rows with 8 different types of valuations. And now what we have to look at is we have to check that all valuations were this true. So okay, this column is true. The conclusion, so negation of A implies Z, also is true. So let's have a look. It is true for this row here. We've got true here, true on this side. We've also got true here, true, 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 and true. So this rule is in fact a sound rule. So if this rule is sound, then by soundness, so by soundness of n, it means that we have, well, this is provable in n, so by soundness of n, this is also valid in propositional logic. So we would have A implies B implies Z is valid. Now since this rule is sound, we can then apply this rule and get from this line we get negation of A implies Z by soundness of the rule. rule, by standards of the rule, we have this, and then we remember that the n system is also complete. So I'm just going to scroll down a bit here. So by completeness of n, from this here, it means that we also have that the negation of A implies Z is provable in the n system. So negation of A implies Z is provable. So that means that we have in fact shown admissibility of this rule in the n system. So the application of PL on line 4 is valid.